Hi, I have an Acura TL 2008 and I recently got the check engine light with code 2P2422, which is the EVAP system vent valve is stuck closed. So I ordered a replacement EVAP canister from eBay, a used one, and I replaced the canister and the check engine light came back on, right? So it didn't fix the problem, and I'm sure the replacement EVAP container is good, right? So when you're fueling up, it comes through here, goes through here, and it's vented. The vented air doesn't have the vapors because the vapors are absorbed by the charcoal. Um, and so now what happens is uh, when you put the gas cap back on after fueling up or when the car is sitting, this part is sealed, right? And now when you turn on the engine, um, this port here, this goes all the way to the front, and there is a valve there, another valve called the purge valve, and through the purge valve it's connected to the engine intake. So when the engine is started and it reaches a certain temperature, the ECU opens the purge valve, which creates a suction on this line, creates a vacuum, right? And so now the vent, the air comes in from the vent in the reverse direction. Remember, when you are fueling up, it was going out, it was being pushed out. And now when the engine purge valve is open, the air comes in through the vent. Vent valve is always open, right? So it comes in, it flows over the first box and the second box, and the unsaturated air picks up the fuel vapors, the fuel which was stored in the charcoal before, and now this air loaded with fuel vapors, it comes out through this port and goes to the engine and is burnt in the engine. So that's how uh, the EVAP system is able to prevent vapors from escaping from the tank into the atmosphere and use those vapors. So the question is, why does this valve exist, this vent valve? Because it's always open, right? When you are fueling up or the car is sitting, it's open. When the engine is running, it's open as well. So why is it there and what's the use? So EPA requires that this whole EVAP system be tested for leaks from time to time, because if there is any leak in any of the hoses, in any of the lines, the vapors will leak out to the atmosphere. If your fuel cap has a bad rubber seal, things like that, right? So it will cause pollution. So the ECU is supposed to periodically check whether the system has any leaks or not. So for that check to happen, the ECU sends power to this vent valve. So when the vent valve is not powered up, it's open. When the ECU sends a signal to the vent valve, actually it's just 12 volts and ground. The vent valve is connected to a 12 volt circuit through a 10 amp fuse all the time. And when the ECU needs to close the vent valve, it grounds the other pin. So that's how the circuit operates. So when the ECU needs to test for vacuum, it grounds one of the pins of the vent valve. The vent valve is closed shut, and the ECU opens the purge valve, which creates a vacuum. After the vacuum, after some time, the purge valve is also closed. Now there is a pressure sensor here. This one, it's called the fuel tank pressure sensor, FTP sensor. The ECU monitors the vacuum decay over a period of time. If the vacuum decay happens before a set threshold, that means there is a leak in the system. So that's how the leaks are tested, and that's the only purpose of the vent valve, is to test for leaks. So now that we know how the EVAP canister, EVAP system works, we can do a quick test. First of all, if you have P2422, which is reporting that the vent valve is stuck closed, but you are able to fuel up, that means that the vent valve is open. Because if this valve is closed, when you are trying to fuel up, the vapors on the top of the fuel tank will not be able to come in because the air pathway is closed shut. So what you will what will happen is it will shut off prematurely the fill process, refueling process. So if you are able to refuel fine, that means you already know that it is not a vent valve shut problem. For what it indicates is that uh, when you are fueling up or when the car is sitting, the venting is able to happen, the air is able to go out, pushed out from the vent. But for some reason, when the purge valve is open and the engine is running, this vent hose is not allowing the air to be sucked back in, right? So this could happen if the termination of the vent is, imagine there is some kind of a box and there is a leaf or some obstruction or a spider maybe, or a spider web, and it is in such a way that when you push air, it's able to let the air out, it goes up. But when you pull, when there's a vacuum, it gets stuck on the hose, right? So it's not allowing that to happen. So if you have this code and if you are able to refuel fine, there is most likely an obstruction like this where your hose is terminating or inside the hose, right? And that's what happened to me as well. So but anyways, let's because we are looking at this canister, let's do some basic troubleshooting and see if this canister is okay or not, now that we know the function. Okay, so the line that goes to the engine, which has the purge valve, I have put some blue tape here to seal that off, simulating that the purge valve is shut. So this is how it is in the car when the engine is off, or when the engine has just gotten started and it has not reached the operating temperature. So the valve is shut and we are now, the vent valve is always open, as I said before. So we are going to simulate some vapors being generated when the car is sitting or when you are refueling. And what should happen is I'm going to blow in this hose, and what should happen is I should be able to blow with ease. There shouldn't be any obstruction and the air should come out of this vent port. So let me try to do that. I'm able to blow with ease and the air is coming out from the vent hose. That means that the charcoal inside the two tanks is not clogged up. Sometimes what happens is if water gets in, or if fuel overflows for some reason and gets into this hose, the fuel can go inside the charcoal canisters and it can clog up the charcoal. It becomes a solid mass sometimes. So we know that because I'm able to blow with ease, that's not the case. The canisters are fine, and also the vent valve is open. It's not stuck closed or anything like that, right? So here is the second test that you can do to determine if the canister is working fine. What I have done is I have taken the line that goes to the engine and connected a shop vac. If you can see here, this is a shop vac, and I have connected it to the vacuum side, meaning it will create a vacuum, right? So this will simulate the purge valve being open and our engine sucking the vapors from the canister. I have also sealed off the gas tank because that's how it's supposed to be, with the cap on. It's a completely sealed area. So this is sealed. There's no air that can come in from there. And so in this configuration, air should go in from the vent hose here because our vent valve is open. It is always open. So it should go in and pick up the vapors and come out from the vacuum. So let's go ahead and start the vacuum. It's going to be a little noisy, but let's go ahead and do that. Okay, so what I've done is I've created some leads and I've connected it to the 2 pins of the vent valve. I have terminated it on this power adapter. You can use different wires or crocodile clips, etc. I happen to have this laying around. So the first thing we'll check is whether the coil of the vent valve is open or not. So if you look at the multimeter, it is showing about 30 ohms. So that means it's not open. So this vent valve should work when the ECU applies power to it. If you see a very high ohms here, like in mega ohms, or if you see it completely open, then the vent valve has definitely failed. So because this is around 30 ohms at 12 volts, it will draw something like 2.6, 2.7 amperes for it to energize. So I happen to have a 12 volt power supply with 5 amp rating. You can also use a 12 volt battery for this test. So we are going to turn on the vacuum cleaner so that it's simulating the engine sucking air, trying to create a vacuum. And because the vent valve is shut, there will be no air going in from here, and there will be a vacuum. So what we'll do is we'll first turn on the vacuum, see if the air is going. It should be going. Then we'll energize the vent valve, and then the air should stop. So that's a simple test. So let's go ahead and turn on the vacuum. So that's a very easy test for testing the vent valve. Whenever I connected the circuit, I supplied 12 volts. There was no air going in, so a vacuum was being created. And when I disconnected, the air started going back in. So that means our vent valve is working perfectly fine. So like I said before, in my case I had the P2422, but my fuel fill was happening fine. That means the vent was able to push air fine, but it was not pull. So clearly there was an obstruction. And in my case, in the Acura TL 2008, this vent hose runs for about 2 or 3 feet back towards the trunk, and just behind the rear driver's side wheel, it goes into the subframe. It disappears into the subframe. I couldn't access it from under the car. Maybe I could have accessed it if I opened the wheel. That's a possibility. But what I did was, I thought if there is an obstruction while sucking, maybe I can attach a vacuum cleaner, right? So what I did was I removed this hose while I was under the car, and I attached a vacuum cleaner like this, and I put some blue painter's tape to try and seal it a little bit. And what I did was I first ran a push. So I was pushing air for about 2-3 minutes, and then I switched the vacuum hose to vacuum. So I was pulling air. So when I started pulling air for the first 15 or 20 seconds, there was no airflow. So clearly there was an obstruction at the end of the vent hose. But after about 15 seconds, whatever was obstructing broke through. So it flowed through the hose and into the vacuum, and the obstruction was cleared. So I kept repeating the cycle. I pushed the air for 2 minutes, pulled air for 2 minutes, for 3 or 4 times. I was satisfied that the vent hose was completely open. I didn't want to put my mouth there because I don't know what would come in from the vent. It could be a spider. So I decided to connect the hose back, and I cleared the DTC, and I've been driving the car around. We have driven over 20 miles. Usually the check engine light comes back on in 4 miles. So there's no check engine light. That means this whole problem was definitely due to an obstruction on the hose or the end of the vent hose. The canister is perfectly fine. I hope this was useful. I hope this can help someone who is running into the same issue with certain Acura and Honda vehicles. Thank you so much for watching. Bye-bye.